Hello and welcome to our iGen 230 team project video for the rope access alert system. In this video, we'll be going over the introduction, communication, validation, conclusion for future work, device housing improvements, alternate designs, and developments. Rope access is a method of working at height where ropes and associated equipment are used to gain access to and from the work position and to be supported there. I have personally worked in rope access for the past 3 years in building maintenance and geostabilization. This line of work can come with a lot of risk, and it is important that when an accident occurs, it is responded to immediately. Our alert system will warn first responders the moment a fall has occurred, giving them as much time as possible to rescue the worker. Because of this, there will be a greater chance the worker will not suffer injuries such as suspension trauma due to prolonged response. Suspension trauma is caused when a person is motionless in a harness for an extended amount of time. This leads to blood being pooled in the legs and unable to circulate through the body, often leading to a loss of consciousness. It is very important that this is responded to immediately. Our detection system for our project utilizes an MPU 6050 to detect changes in acceleration. Using the X, Y, and Z accelerometers, we are able to detect the device is in free fall due to the lack of gravity being present. From there, we are able to tell the duration of the fall and the force that was applied in order to arrest their fall.
The two main features of our project contained inside the product chassis are the MPU 6050 and an Arduino MKR NB1500. The MPU contains an XYZ axis angular sensor and an accelerometer, and it sends its inputs as digital outputs to the Arduino. The Arduino MKR has a rechargeable battery attached as its power supply and has as its inputs two push buttons, one for activating alerts and the other for canceling them. Its outputs are an RGB LED and a buzzer. The MPR contains a low-power chipset which contains a SIM card reader. We use this feature to send SMS text to our receiver, typically the phone of emergency personnel.
Now we'll be discussing the communication system. From the hardware side, our device uses a modem and SIM card to send SMS texts over the LTE network. With respect to the hardware, when a user is in distress, the system will send an SMS text every 30 seconds until the user has determined they are no longer in distress. When a user has determined they are no longer in distress, the system sends a "I am safe" text message, which indicates the user has manually deactivated the alert system. While all of our components work individually, due to time constraints, we're unable to come up with an integrated product. But here's the closest thing we have, which is the testing rig for our push buttons, speaker, and LEDs.
In order for this device to be used in an industrial environment, we needed to design an enclosure that is water resistant and durable enough to survive a fall with a rope access worker. To achieve this, we 3D printed the housing out of PET plastic with thick walls and rounded edges to mitigate stress concentrations, and then added gaskets around ingress points to seal the device. We also designed the device to be operated under high stress conditions. We used large, easily pressable buttons and recessed them to prevent accidental presses, and then installed a power switch with a cover to clearly indicate when the device was running. Finally, to connect the components to the Arduino, we used a proto board. This gave us a quick way to make compact, secure connections.
A feature we were unable to implement on our device but we'd like to implement in the future is its ability to receive SMS text. Another feature is its ability to pinpoint the location of its user using GPS. A change we'd like to make on our hardware is to allow it to be more waterproof. Additionally, we'd like to be able to create a custom PCB instead of having to use an Arduino development board, because there are some aspects of the MKR1500, which was the development board that we used, were somewhat overkill.
If we were to continue development on this rope access alert device, we would revisit some alternative designs we had to discard due to time and cost restrictions. First, we would revisit the idea of using an Iridium modem. This would allow the device to send alerts anywhere on Earth using the Iridium satellite network. This would have been ideal because rope access work is often done in remote locations, but the cost of the modems was prohibitively expensive. We would also revisit the idea of using sensors on a smartphone to detect a fall. The majority of smartphones have similar IMUs that we could use. This would have made the technology more accessible since an employer likely wouldn't have to purchase any new equipment. However, we ultimately decided against the idea because of concerns regarding reliability and the difficulty of development. Finally, we would revisit the idea of using alternative sensor designs such as a barometer or tension gauge. These sensors would allow us to create redundant systems in the device, which would improve the reliability of the fall detection.
With regards to continuing development on this project, we're looking to optimize the device's user interface and also create a user manual for people to use it. Thank you for taking the time to listen to our video.